Hello, everyone. My name is Chris Mancuso, and I'll be going through the walkthrough of the GenePlexus web server. If you'd like to see a video on a little bit more in depth about the actual machine learning model that is used in this, see the link to that video in the video description below. So welcome to the GenePlexus web server. So the main function is that the researcher is allowed to upload a set of genes that they are interested in, and then we will use genome scale molecular interaction networks to kind of predict things about the gene set and also maybe do a little bit of interpretation of the gene set. So what the user will do is they'll come to the website and then they will upload a set of genes of interest, and they will choose between a couple different networks, how those networks can be represented, and like how to select background genes. Then a machine learning model will be trained. And the main thing that will happen is that for every gene in the genome or in the molecular network, it will be predicted how associated it is with the input genes. And then we also will try to interpret the model by comparing it to thousands of other trained models. And then we'll also be able to visualize the top genes in the context of how they're connected in the underlying network. And then these can all be retrieved through an interactive browser. So there's about the landing page. There's a little bit more about the help and about and the tutorial. And then there's a little bit of a description about a kind of an illustrative example of how it can be used. So to start, what the user will do is the user will come up to this button up here and then click to add genes. So I had already kind of preloaded some genes. There's some samples. You can either download the file, then upload it, or you can just click it here. So a user can either upload it from a file or they can copy and paste in here. And then once genes are in here, you can add genes as you please. The only thing is currently in this version that you have to be on a new line. So once a user uploads their genes, they'll click the done button. And then what is going to happen is that these genes are going to be validated. So what will happen is that some information about the networks will be returned. And then so the number of nodes in the network, the number of edges, and then also the number of genes from the user gene set that were able to be converted to Entra's IDs, and then that are also in the network. And everything is converted to Entra's and IDs because that is how all our networks are and all our gene set collections are in. So what will happen is the user will see their original IDs. Then if it was able to be converted, it will have the Entra's ID here. If not, there will be an NA, and then it'll be for each gene specifically, was that gene in that given network. So then a user can peruse this file and then kind of maybe get an idea if they want to go with one kind of network over another. So once the user kind of has an idea of maybe how they want to proceed, then they will interact with this panel over here, which is what they'll use to submit a job. So what you can do is you can enter an optional example job name. So GenePlexus automatically makes a job name of alphanumeric characters. But you can upload or you can add a specific one for to your liking. The maximum limit of characters is 32. And then also we do something called slugify for security purposes that changes some characters to a certain other different characters. So people can't put things in that can kind of control the web server kind of illegally. So you can put that in. So it's always good to check what the actual outputted gene job name was. So then we can select the different networks. So you can select which network you want. So we have BioGrid, Giant, String, and the experimental version of String. There's more details about what the difference between these are in the help and about pages. So we're going to select here, and then you can also select how you want the features represented. So this is in the machine learning. Adjacency is kind of using the connections as they were in the original file as as the features. Influence is using a random start with rewalk kernel to kind of diffuse the edge information. And embedding is using the node to vec algorithm to make a low dimensional vector for each node. So we'll click embedding here and here, and then down here is the notification of an email. This is completely optional, but if I want to put my email in there, I will get a job submitted to me. I'll get an email when the job starts, and then also another email when the job is done. So I click the submit button. And so what we can see here is now it takes you to the job pages. So typically jobs take a few minutes, usually no more than 10, but it can depend on so when you click the submit button, some resources are allocated on Microsoft Azure, and due to the slow, the latency on the cloud at the time, it could take a little bit longer, but usually no more than 10 minutes. And so what we can see on the jobs page is it'll give you the link to the job where the results page will end up. You can also see that it was submitted, and you can see some of your past jobs. So now that this is working, so this will take a few minutes for this job to submit. So what we're going to do is just going to go to a previous job, and this is the same example that's used on the website. So this is now when you click the link, you get to the results page. So on the top here, it's all the information that was kind of used that the user selected to run the job. So it gives you the network, the features, and the negative class, and the job name. We also report the median value of doing 5-fold cross-validation on the gene set, if there are enough positives where we can do 5-fold cross-validation. So we extensively benchmarked this method in another work, and there we used a whole bunch of different validation schemes. But for the web server, we use 5-fold cross-validation to give some kind of context of how well the model performed on that given gene set. So the first page that we get to are the gene predictions, which is the main feature of the GenePlexus web server. So what we see is that we get a table back that's sorted by probability. So we get the information, first few columns are information on the genes, the NTRES IDs, the symbol, and the name of the gene. Then we can see the prediction probability. And then we can see whether it was known or novel. And known is basically, it was used inside it was known to be a positive before. And then novel is, it was not known to be a positive in the user supplied gene set. So we can see there's one novel here. Training labels are very specific to what was actually the class of the gene during the machine learning model. P stands for positive, N will be negative, and U will be, it was unused during training. And then we also supply the ranks. So we can see here that there's a lot of known genes, as will be expected, because those are considered positives for sure. But then GenePlexus can predict new novel associations. So another key aspect, a very unique aspect of the GenePlexus web server, is that we try to provide interpretation of the model. So what we have done is that, so when for each of these networks, features, and negative classes, we have trained machine learning models for all of those specific combinations on thousands of diseases from DisGeneNet and biological processes from the gene ontology. So we have all those pre-saved. So when we train a model for on the user supplied gene set, we can kind of compare those to all these other previously trained models. There's more information in the about section or the help section about whether exactly what the similarity score means, but we can kind of rank the similarity between the user model and a bunch of models trained on known gene sets. So that's what's presented in this tab. And so here we can see, similarities to other biological processes, and then similarities to other diseases. And then this is, so these tables right now, they display the top 500 results, same with the gene predictions. However, if you want to download all the predictions for the gene predictions, you can have anywhere between 17,000 and 25,000 genes, which the association was predicted for. If you want all of those, you can download all of them using these buttons on the side. Also, I forgot to mention that if you want to download everything all at once, there's one convenient button that downloads everything. So the last way to try to interpret, give some kind of context of the gene set of interest is that we display a network graph. So what we can do is that this is just the top connectivity of up to the top 50 predicted nodes. So the top 50 nodes with the top 50 prediction probabilities. So the sliders here, we can change like just the number of nodes we want to see, kind of change the edge weights, a threshold. So it'll either get rid of the edges or add edges. And then we can grab nodes and have them stick. So if you see, in this case, there's one node that's a unlabeled node. And so people might want to see how it's connected to the rest of the nodes. And we can see that it's very highly connected to a number of the other nodes. And then if you click on a node, you can then see what its rank was, its NTRES ID, and then click on a link here, it goes to the NCBI page for that gene, and a couple of just some more information about this. And you can save this kind of network in a number of useful formats. The last tab is the input genes. And so what this is just kind of a summary of the genes that were used for positives when training the machine learning model. So a user doesn't have to kind of remember what the positives were. So all of this information is kept in one place. So a user should be able to kind of know exactly what they put in, and then they can save all the results as well. So that is kind of the basic walkthrough for the web server. So we also have fairly extensive help pages and an about page. Contact. So we are really interested in feedback. So any kind of features or anything we want, we are actively monitoring that email. So any comments or suggestions are welcome. So I guess one last thing to mention here is about cookies. So when you first come to the website, there's a message about cookies. So where cookies are used are when you have this loaded gene set. So as you navigate through the panels here, this gene set persists, and that persists through cookies, but it's very useful to have that. So every time you click a button, the web server doesn't forget it. Also the jobs page, we can now notice too, the BioGrid embedding job is done. That the job, it remembers the jobs as you go. So it's a little bit helpful to have this in there. So we notice that we don't have any login informations or user accounts set up at this time. And we want to be explicit. We're not using tracking cookies or cookies for anything like that. We're just kind of being able to use cookies to make the website more user friendly. So I hope you liked, I hope you like the web server, and we're very receptive to any questions, comments, suggestions that you might have about it. All right. Thank you.